Namaste and welcome back to this FreeRTOS series on this channel where we are running the FreeRTOS API in the ESP-IDF environment using our ESP32 module. So let me head to VS Code and show you the progress that we have made till now. So we have covered xtask create API and xtask create static API in the previous two episodes on task, and we have also discussed few of the other task specific APIs, but we figured to go ahead with these two APIs to show in action. So we discussed how you can use xtask create, how you can pass a param to this particular task, and we just printed some particular messages, and then we used this vTaskDelay here, and this is our topic for today's discussion, that is delay. Now why we used this, we showed you that the watchdog was triggered if we were not using this because the ideal task was not getting any time, right? So that was the reason we implemented this delay, and this is a non-blocking delay, that is. And for the create static one, we had a certain stack size and then certain task stack declared and a TCB structure declared. So moving on, we will discuss two APIs today, that is vTaskDelay and vTaskDelayUntil. So this is our vTaskDelay API in the ESP environment, and it is almost similar to FreeRTOS. So what does it say? So here it says delay a task for a given number of ticks. Now what is a tick? Ticks you can assume like a particular interrupt, a tick interrupt. Like the closest example can be that of a clock. After every second there is a tick sound coming from my clock. Tick, tick, tick. So the period here is of 1 second. You can have a better clock and that can give you a much precise tick, but for an example point of view, ticks is something that is repetitive, and in our case it depends on a rate that is being set. Let me show you what is the rate of tick in our ESP32 by going on to menu config. So idf.py menu config. In this, under the component config and then moving on to FreeRTOS kernel, here is our config tick underscore rate underscore hertz, which is 100. If you convert that into time period, that is around 10 millisecond. So after every 10 millisecond, our ESP32 has a tick interrupt. So if I want a delay of vTaskDelay of, right now we are using this function, that is td millisecond to ticks, wherein we provide the duration in milliseconds. So this is almost 1 second, right? 1000 millisecond. So we are passing millisecond, and that is eventually converted to ticks using this function. But let's say you don't want to use this function, then what would have been the value? Guess it. I told you 1 tick is 10 millisecond. So for 1000 millisecond, how many ticks? Yes, 100. That's right. So that's the trick. This one needs a tick type underscore t x ticks to delay, and this is also another way wherein people use this particular port tick underscore period underscore ms, and in the front they have the millisecond that they want delay for. You can use this also, but the best method I think is this ms to ticks. That way you don't have to search for what is the tick count for your particular controller. You just straight away give the millisecond value, and that is eventually converted to ticks. So this is vTaskDelay. So right now I have vTaskDelay function for both of these tasks, and Let me add one more print statement wherein I will just be printing the tick counts. So hold on for a while. So what will this xtask get tick count give us? It will give us a tick type underscore t variable and the count of ticks since a vTask start scheduler was called. Basically it gives us the tick counts from when the task started. So why am I printing this exactly? To show you what would be the difference when I introduce you with vTaskDelay_until. So let me just upload this to my ESP32. So now, well, I missed a new line print anyway. So now let me just exit this and show you. So here we are on the beginning 1 1, then 102, 202. So basically, what happened here? I told you that config tick hertz was set to 100 hertz, and accordingly, that means that 1000 millisecond means 100 ticks, right? So it started with tick 1, but next it should be 101, but it is 102. They started with 1 instead of 101, this is 103. Then 102 plus 100 is 202, cool. 103 plus 100 is 203. 202, 302, 303, 402, 403. Okay, so that is consistent. But since we are just using one thing, and that is ESP log I, imagine if we would have added certain more things to be done in a given task. Imagine what would have happened to this timing in ticks. So basically what vTask delay does is that it delays for that particular amount of time after or at the point after which it is called. Let me give you a more straightforward example. Like for example, let's say when vTaskDelay function is called, printf and ESP log I, let's say they take around 5 milliseconds to execute. After this 5 millisecond, another 1000 millisecond would be used by this vTaskDelay, right? So overall time taken by this vTaskDelay would be 1005 milliseconds, right? But if I introduce vTaskDelay_until, what this does is that this provides us with a periodic execution of our task. So now if printf and ESP log I takes 5 millisecond, this will take 995 millisecond, eventually making this complete task in a period of 1000 millisecond, and we will see that in this example. And it needs a tick type underscore t pointer as a previous wake time and a tick type underscore t x time increment. So this delays a task until a specified time. Okay, so cool. Now we have added vTaskDelay_until, and as I said that this takes a periodic approach of our task. Let's now see what is the difference between task get tick count for both of this. Let me add a new line here so that it's properly visible. All right, I'll go ahead and again flash this to my ESP32 controller. Okay, we have the result. Let me pause it. So here we have again the starting tick to be 1 for both of this task. But wait a minute, there is a surprise. Task B now is at 101 tick, exactly 100 ticks apart. Task A is now at 102, which is 101 ticks apart. See the consistency of B now, it is exactly 100 ticks apart. So see, Now you would say that that's not much of a difference, one tick, 601, 602, that's it. But imagine this is just for one single statement of ESP log I. What if you execute things that require more time? So let's say if that takes around 500 milliseconds, then this whole task would go like at a rate of 1500 milliseconds, because 500 milliseconds for that particular task or particular code execution in this, and then 1000 millisecond of delay, that will give this 1500 millisecond. But at the same time, if I have used until, delay until, then if this particular code took 500 millisecond, this will ensure to take another 500 millisecond and execute this whole task in 1000 milliseconds. Sorry. So you get the point, right? If you want a periodic execution of your tasks, then go ahead with until. If you are okay with like certain tasks don't require that kind of periodic execution, so no need to add few lines of code, few variables, just go straight ahead with task delay. Hope you got the point of this delays, and these are the two delays that we specifically use in FreeRTOS. If you like the video, give it a thumbs up and share it with other people and share this knowledge to them as well. Obviously, if you haven't yet subscribed the channel, do subscribe it and hit the bell icon. Signing off.